so you have a little extra to work on. Let's call it just extra practice. It's for your test, so it's a good thing. Here are 3 lines. Which line is the steepest? Explain your thinking. Well, before you start inventing stuff, what I would do is find the slope. That way you can get credit. So for this one, I'm going to pick this point and, oh boy, this point. That's 1 and that's 3. So the slope of this one, it's height over base, 3 over 1, or just 3. For this one, pick this point, and you got to pick 2 points on the line. It's extremely important you do that. So here's my triangle. The slope is 2. The height's 2, I should say. 1, 2, 3, 4, 5, 2/5. And the last one, pick 2 points. I'll pick this point and I'll pick this point, which makes like base 1 and the slope 2. So height over base, 2 over 1 or just 2. And just by looking at the numbers, right? I don't know. Think of the example I give in class. You know, you want to take my mom, my 84-year-old mom, up for a hike, which is the steepest mountains, which is the one that she wouldn't be able to. Definitely, I mean, she can't. Maybe this one, but in the context of the question, the steepest is this one, right? If you can look at the slope, it's also the greatest one. The slope is 3. This one is 2 over 5 or 0.4. And this one, slope is 2. It's still steep, but the steepest one is this guy right here. Okay. Polygon A, polygon B are similar. Whatever. Okay. And what are we asked to do? We are asked to describe the sequence of transformation that moves polygon A to polygon B. Okay. So we're going this way. So obviously there's a rotation, right? So there's a rotation, right? So if you actually, let me change this because that's confusing. Let's rotate this A this way. If we rotate that way, you can see that that becomes this. So A becomes B. The shapes move, so it's a rotation 9 degrees clockwise. So that's one of the transformations. The other one is a dilation. A dilation of what? Well, it definitely got smaller, so pick a side. Let's pick this guy here. It's 1, 2, 3, 4, 5, 6, and it's now 1, 2. So it went from 6 to 2, right? So what's the dilation factor here? Is dilation of 1/3. So I know you're going to say divide by 3, but think about the reciprocal, right? The reciprocal is 1/3. So it's a dilation of 1/3. So this side is 1/3 of this. Make sense? And then there is a translation. It's so tough when they do it this way. There's probably there's a translation. We're going from A to B. So this, if we translate it, and this being the center of dilation, the initial shape after dilation. So let's dilate this first. So if you dilate it, so it went from 6 to 3, 6 to 2, but this would have been the new shape, right? So you get something like this. And this top part, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would actually be 3. So imagine this, 2, 3, 6. So we would actually have something. If we dilate it, right? So that K became a small k. We will rotate, and we rotate this goes that way, and then we'd have a dilation of a few units going down. So if we dilate that, oh God, why don't they do this? Dilate that. This would be, let me change colors. 1, 2, 3. 1, 2, 3. Yeah, dilate like this. Change colors, please. Okay, so your K would be like this, right? So let me put it in order. Dilation of 1/3, rotation of 90 degrees, right? So you can see that this is rotating that way, 9 degrees clockwise. And then from here, it would have to go, let's see, this point, to get to this point, it'd be 2 to the left, and 1, 2, 3, 1, 2, 3, and 4 down. There's your translation. Jesus. 3. Quadrilateral ABC is dilated using point C in the center, and then the scale factor was what do you call, 2. So we're gonna get a shaped polygon that's twice the size. So it's from here that you dilate. Okay. So how do we get from C to B? To go from C to B, we're gonna go 1, 2, 3, 4, 5, 6 to the left, and 2 down. So times 2 times 2, we're going to go 12 left and 4 down. So 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, and then 4 down. 1, 2, 3, 4. There, and there's B prime. Okay. A prime, so C, again, C to A. We go 1, 2, 3, 4, 5. 5 to the left. And 1, 2, 3, 4, 5, and 5 down. If you multiply those by 2, because that's the scale factor, you get 10 left and 10 down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here's A prime. D prime, so sorry, C to D. Because C's our point center dilation. To go to C, we're going to go 1, 2 to the left. And to the left, and 1, 2, 3, 4, 5, 6 down. So double that. We're going to go 4 left, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's point D prime. So if you were to connect the dots, this is what you get. Similar, right? Corresponding sides are proportional, and the angles are congruent. All right, that wasn't that bad. My pen is not working. Okay, here we go. No, here we go. Now I need a new tablet. Okay, here's a triangle ABC. Draw a dilation of triangle ABC using point A as a center dilation. So we're gonna do, come on, pen, everything from this. Sorry guys, my pen is not obeying me. So remember, dilation and a half, the distance gets cut in half. Okay, so no, all right, here we go. So from A to B, well, cut that in half. Here's B prime. Come on, B prime, right? From A to C, cut it in half. Here's C prime. And this one is easy. Notice that when we had one of those questions where they said, is the line going to be parallel? There you go, they're parallel. Okay. Draw dilation of triangle DEF with a center 0, 1. Here's the center, right? So everything's going to be measured from that point. Everything's going to be doubled from the distance that you are from that point. Scale factor of 2. Well, so walk to E. To walk to E, you go 2 units to the right. So to walk to the new location, you would walk 4. 1, 2, 3, 4. And here is E prime. To walk to F, I would go 1 up and 2 to the right. So I would go 2 up and 4 to the right. 1, 2, 3, 4, and that would be F prime. So the new triangle, notice, similar, right? A new dilation with center 0, 1 sends point F to 9 and 5 point and a half. 9, what is the scale factor? Alright, so question B, you start at, here's your dilation, send dilation, and you're sending point F to 9. So like 9 would be here, 9 to the right, and 5 and a half up. So about there. What is the center of dilation? Well, sorry, what's the scale factor? So the original, to go from D to E, so think about this. To go to F, right, to go to F originally, from D to F, let me just write this down. It's 2 to the right and 1 up. Everybody okay with that? To go to the new F, you're going to go 9 to the right. So to go to from D to, and let's call it F prime, to F prime, oh my God, sorry, to F prime, they're saying that you're going to walk 9 to the right and 5 and a half up. What's the scale factor? Well, zero and 1, you walk 2, hang on, so if you think about just here, right, from here, from 2 to 9, so this initial side is 2, and then the second one is going to be 9. How did the 2 become 9? Times 4.5, and that's the scale factor. Okay. And if you look at going up, right, going up we go 1, 2, 3, 4 and a half, right? So before, to go up to point F, it was 1. Now it's 4 and a half. So this is 4 and a half, and this is 1. So how did the 1 become 4 and a half? Times 4 and a half. Before, this was 2, and now it's 9. How did the 2 become 9? Times 4 and a half. So the scale factor is 4 and a half. 6. What in the world? Triangles GHI has vertices, so let's draw the triangle at 0 and 5. 0, 2, 4, 5. So here's point G. Point G. 2 and 0 is point H. And 5 and 3. 5 and 3 right here. And this is point what? Point I. Notice that we have a triangle. And then triangle JHI is the result of dilating the triangle using the origin from here. So we got, remember I told you when we did dilations, find the origin. And we're going to dilate this using a scale factor of 2. So this one's not that bad. So from the center of dilation, which is here, the green point, how do I go to H? I take 2 steps to the right, but with a dilation of 2, right? So we're going to multiply at 2, so I would go 4 steps to the right. So this is H prime. From the center, right center, how do I go to G? Well, to go to G, I would take 5 units up, but because of a dilation of 2, I now have to go 10 units up. So this is G prime. To go to I would go 5 to the right and 3 up. So double those 2. I'm going to go 10 to the right and 6 up right here. And this will be my point I prime. So the new triangle, it's right here. Okay. This graph shows two slopes. Determine the value, a possible value for A and B. All right, not that bad. So if this is 2 and 3, notice that they're similar triangles. They are on this, they're using the line here, the slope of the line, right? Both points are on the slope. So this is bigger. The slope of the line, let's answer B. What's the slope? Height over base. And we're going to use a smaller triangle to find that ratio. It's 3 over 2. This triangle over here, it's bigger, right? It's similar. We know it's similar because it's these 2 points are on the line. So I don't know, use a scale factor of whatever. Let's just use scale factor of 3 times 3 times 3. So a possible value for A and B could be 6, 9. There we go. 8. List the figures that are similar to A. Okay. So easiest way to do that is put some values. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. The top is 2. This is 4, and the top is the top is 1. Are they similar? Yes, they are, because look, 2 divided by 2 is 1, 8 divided by 2 is 4, so this is a candidate. It's one of the possible answers. This is 1, 2, 3, 4, 1, 2, 3, 4, 5. This is 6, and this is, what is that? 1.5. How did the 2 become 1.5? Well, it's definitely not the same way as 8 becoming 6, or look otherwise. 1.5 times 2. What times 1.5 is 2? Is it the same scale factor as 6 multiplied by 8? 6 multiplied by the same factor to get 8? Obviously not. So this is not it. B, this is 1, 2, 3. Is it? 1, 2, 3. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How does a 2 become a 3? Well, times 1.5. Right? How does the 8 become a 12? Times 1.5. So notice that corresponding sides were multiplied by the same scale factor. So this is definitely a similar triangle. So, and what about D? Well, I don't know. This is 1, 2, 3, 4. So if this is 16 here, we're good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It is 16. So notice that 8 scale factor times 2. 2 to get 4. Scale factor times 2. It's the same shape. All the angles are congruent. And we are good. Oh, there's 2 sets. Sorry. I guess we're doing all of them. Here's the slope with the steepest. Again, think about, obviously it's not E, right? Think about mountain and climbing out the mountain. So E is the easiest, so that's not the steepest. That's between F and D. I thought they looked parallel, but they're not quite parallel. So let me pick 2 points. Let me pick this guy, another point in the line, this guy. Draw triangle. And let me see if I can find the slope. This is 2. This is 1, 2, 3, 4, 5, 6. 6 over 2. The slope is 6 over 2 or 3 over 1. This one, the slope is, let me pick that point and this point. 2 points that are on the line. This is 2 and this is 1. So the slope is 2 over 1 or just 2. So in order, the steepest one is this guy. First place steepness. Second place in steepness, and then the easiest one, 3rd place. Are these 2 similar? Or describe a sequence transformation that moves polygons. So this became that. So obviously a rotation of 9 degrees clockwise was involved. Definitely a dilation. Of what factor? Well, it got smaller, so let's just, so this side here corresponds to this. It used to be 3, now it's 1. So what was the dilation? 1/3, right? Do they really want, and then what do you call translation? Yes, you definitely have a translation. So if you take this, let's start, and I don't know, let's do a, sorry guys, dilation. 1, 2, 3. Right, so if you dilate this by everything by 1/3, this would have been your dilation, your figure after dilation, right there. And then notice that we have to rotate. So if you rotate this, eventually the shape, this shape, which is pointing that way, will now point this way, and let's just shift that. So it looks like this now. Let me change the colors. Right, so I can imagine that. It would look like this, right? So a dilation of 1/3, that's number 1. A rotation, that's number 2. And then we got to take this shape that I do in red and move it all the way here. So pick a corner. Let me pick this guy here. Change colors. How did this corner get to this corner? And that, once you find that translation, every point in that shape obeys that same rule. So it would be 1, 2, 3, 4, 5. Looks 5 to the right. And how many down? 1, 2, 3, 4, 5, 6, 7, and 8 down. And that would be the translation. So this red polygon will move 5 to the right and then 8 down. Right? Right. Quadrilateral ABCD is dilated using point C. So everything is going to be from here. Half. Right. The easiest way to do, it's always in this case, cut your horizontal and vertical distance in half. So from C to B, if I were to walk from C to B, I would go, oh my God, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I would go 12 right and 1, 2, 3, and 4 down. Well, cut that in half, which means that from C prime to B prime, it would be 6 to the right and 2 down. So 1, 2, 3, 4, 5, 6, and then 1, 2. And here's my B prime. Here's C prime. To go from C prime, to go from C to A, you would go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to the right. And how many down? 4, 5, 6, 7, 8, 9, and 10 down. Cut that in half, it'd be 5 and 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this would be A prime. D prime, let's cut that in half again. So from C to D, it would be, oh my God, let me just count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going 6. And how many to the 1, 2, 3, 4. So it's 4 to the left and 12 down. Cut that in half. We're going to go 2 to the left. 1, 2, 1, 2, 3, 4, 5, 6. And here would be, and here would be D prime. So there's your new shape. Okay. All right. A silly question here, right? Here's a triangle. Draw dilation of triangle ABC using point A, and then dilated scale factor 2. So A to B is that distance. So to B prime, let's double that distance. So it'll be somewhere around here. I'm not going to use a ruler. So A prime. A to C is that distance, so double that distance. So C prime would be somewhere over here. And there's your triangle. Right, that one wasn't crazy. Draw dilation of triangle DEF, okay, using 4, 3. So we're talking about this guy. Here's our center dilation line. Label it in green. And we're going to double the distance from F to E. Get scale factor. So from F to E is 1. units. So from F prime to E prime would be 2 units. So here's my E prime. From F to D is 2 left, 1 down. So it's going to be 4 left, 2 down. So this is D prime. There's my new triangle. Okay. The second question here says, point using a new dilation using 2 and 2 as a center dilation. So here's my center dilation. And sends point F to 11. So 8, 9, 10, 11. So pretend this is 11. 11 right here. And to 11, 6.5, which is about here. So the new point F would be here. Well, easiest way to do it, and like I said, is just compare the corresponding sides and see what scale factor. So from D to F, I'm going to take from D to F, right direction, I go 2 right, 1 up. But they're saying that from D prime to F prime, which is right over here, right, this guy right here, I have to walk, let's see, to 11, so 11 minus 2 is 9. I go 9 right, and then 6.5. But I'm already on 2, so 6.5 minus 2 is 4.5. So 4.5 up. So now ask yourselves, how did this 2 become 9, and how did the 1 become 4.5? Scale factor is 4.5. 6. Oh geez. 2 triangles again. We're dilating. Where's the center? The origin is the center dilation. Okay, so that makes it easier. Point GHI 03 right here. This is G. H is 4 and 5, which is right here. And I is somewhere over here, 3, 2. This is I. So the triangle, right? So the green one's my center dilation, the origin of my center dilation. So everything is gonna get, again, doubled. So ask yourself, how do you go to G? To go to G, right, I go 3 units up. So to G prime is gonna be 6 units up. So there's where G prime is. To go to I go 3 left and 2 up, so 3 right and 2 up, so we're going to go 6 and 4 up. And this is I prime. To go to H, we went 4 right and 5 up, we're going to go 8 right and 10 up. And this is H prime. So that's my second triangle. Here's a slope of 2. Let me just do this. Well, the slope here of this is 2 over 3. Right, we know that because it's height over base. We know the slope is 3. This is a bigger similar triangle, so they scaled it up by a number greater than 1. Pick 1. I'm going to pick 2. So let's do the scale factor of 2. I multiply 2 by 2, we're going to get 4. I multiply 3 by 2, we're going to get 6. So this is a possible 4, and this is a possible 6. What is the slope of that line? It's also 2 over 3. Why? Because those 2 points are on the line and they're similar. Yay, last problem. List the figures that are similar to A. Okay, let's get some units here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Is that 8? All right. 4 and 8. Let's look at E. That is 2, and this is 1, 2, 3, 4. So that's scale factor of 2, definitely a potential. So E. Let's look at A. A, this is 3. So the 2 here became a 3. Let me change colors. Right, so corresponding, the 2 became a 3. How? By multiplying by 1.5. So 4 times 1.5, this should be 6. Is it 6? I don't even know what that is. It's between, so that's a half. 1, 2, 3, 4, 5. And is that even a half? Listen, I'm not going to use that because I can't actually tell the value. So that one's gone for me. B, 1, 2, 3, 4, 5, 6. So this is 6. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That looks like a 12. How did the 4 become a 6 times 1.5? How did the 8 becomes a 12 times 1.5? Same scale factor? Yeah, so B is candidate. What about D? Of course, 1, 2, 3, 4, 5, 6, 7, 8. So that's an 8. So if just the bottom one is 16, we're good. Shape looks the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 16. Look at that. So what's the scale factor here? Times 2 times 2. So E, B, and D are similar to figure 8. All right, that's it.